Students, in our previous classes we have discussed about voltage, current and resistance and all, isn't it? So now we will see what happens when we apply certain voltage across a resistor. Okay, so here I have drawn a circuit. Okay, so wherein we have a voltage source V, and because of this voltage source, and this is called as what? An electronic circuit, isn't it? Or electrical circuit we can say it as. So what is electrical circuit? Electrical circuit is nothing but what? It is an electrical path, or what we can say it as, it is a path for or closed path for electric current to flow. So electric circuit is a thing, or it is a way wherein the current flows, isn't it? So if it is somewhere open, then there is no question of current flow, isn't it? Yes. So we need to have a closed path so that current can flow, and current always flows from positive of the battery towards negative of the battery. This is a voltage, DC voltage source what I have connected, and here we have a resistor or resistance of R. Okay, so R ohms of resistance it has got. Okay, so we can have values of resistances as 100 ohms, 1000 ohms. So likewise we can have many values of resistances. We can have also mega ohms of resistances we can have. So the range of values will vary for different type of application. Okay, so now we have considered a resistor of resistance R. Okay, so what is resistor? Resistance is what? Resistance is the property of material to oppose the flow of electric current. So that is called as what? Resistance. Okay, so now each and every material, so whatever you have in the universe, everything will have certain resistance, isn't it? So some of them will let electric current to flow through them, some of them won't let electric current to flow through them, some of them will let 50% for the electric current flow. Okay, so likewise we have different categories of conductors, semiconductors and insulators, isn't it? So I have considered the resistor. So resistance is the property, and what is resistor? What is resistor? So resistor is what? Resistor is what? It is an electronic component, so which is having some material to oppose the flow of electric current. So it is an electronic component, resistor. So resistor will have certain resistance. So that is represented. So that will be measured in terms of what? Ohms. Okay. So ohms unit has been given to this because of your ohms law. Okay. Yes. So now we have applied certain voltage and current starts to flow in the circuit. So this is called as what? Electronic circuit or electrical circuit we can say it as. So this is electric circuit wherein the current is flowing and we have a resistance. So what happens here is, so as by Ohm's law, we know that from Ohm's law we can denote the equation or relation for your current and voltage as what? V is proportional to I, isn't it? So what does Ohm's law says? Current flowing through a conductor is directly proportional to the voltage applied across its ends, isn't it? So we have voltage applied is proportional to the current which is flowing into the circuit. Okay, so this proportionality is taken with the constant of V is equal to I into R, where R is the constant of proportionality, and it is called as what? Resistance, and it has got a unit, SI unit of what? Ohms. Okay, so now likewise we can make out the thing. Okay, so now what happens here is, so if I have certain voltage applied and current starts to flow and we have certain resistance, so that means what? The voltage applied and the current is flowing, and this current depends on the resistance over here also. Okay, so voltage is directly proportional to what? Current, not voltage, the current which flows through the circuit, it is dependent on what? The resistance. If I go for current equation, I will be equal to what? If I take it this side, it will be V divided by R. Isn't it? So with this, I can say two of the things. Directly proportional means what? Direct proportionality. Okay, directly proportional means what? If something increases, the other thing also increases. Okay, if something increases, other thing also increases. If something decreases, the other thing also decreases. This is what is called directly proportional things. Okay, so now coming to inversely proportional things. Here I can make out I and R are what? Inversely proportional. Inversely proportional in a sense, what? I and R are inversely proportional. I and V are directly proportional. Okay, so I and R are what? Current and resistance are inversely proportional things. So that means what? If what happens here? If resistance is more, current will be less. If resistance is less, current will be what? More. So what happens here is, so the voltage application will be there. Fine. So after applying the voltage, current starts to flow in the circuit, and this current flow will be dependent on what? The resistance connected. If you connect like a resistance of high value, means if resistance is more, current flowing through will be less. Why current flowing will be less? Because resistance is nothing but, or resistor is what? It is a component which opposes the flow of electric current. So it is resisting the current to flow through it, isn't it? So more the resistance, more will be the opposition, or more will be the or like opposing force, isn't it? So it will be not letting your current to flow easily. So that goes to some opposing feature, so that current will become less, current flow will become less. So then what we can make out here is, so I have applied voltage and current will be flowing, and this current flow will be dependent on what? The resistance of this resistor. So conductor wire will be there, and let me take, so usually they will use copper wires. Okay, so because copper is the best conductor of electricity, best conductor of electricity means what? It will be having least resistance. Okay, so best conductor means what? It will be having least resistance. Least resistance means what? It will have less opposition, or less blockage for your current to flow. Okay, so now I have used conductor wire, and this conductor wire also will have certain resistance. Okay, so I said that it will be having what? Least resistance. So what is that? Least resistance is what? Very less resistance it will be having. Okay, so when I have certain resistor over here, or some bulb I have connected, so bulb is a thing, then it will have some resistance, isn't it or not? Okay, so whatever it may be, so this resistance of any of the load connected, so this is what is called load, isn't it? Load. So this is getting this voltage in the form of what? So when the current flows, this voltage will be utilized by the resistor, isn't it? So or we can say it is not load, and this is your source, isn't it? Yes. So now what happens here is, so the applied the resistance of this resistor is far greater than the resistance of this conductor wire, and resistance of conductor wire of copper, because it's the best conductor of electricity. So the resistance of the conductor wire will neglect it. Okay, what will you do? So resistance of this conductor wire will neglect the resistance of the conductor wire, and whatever resistance we consider is only the resistor's resistance will consider. Okay, is that okay? So we can't say that something is not we have copper wire, best conductor of electricity. That means what? It doesn't mean that copper will not have any resistance. It will have resistance, so it will be very less. So negligible amount of resistance will be there, and that is how we won't, that is why we won't consider the resistance of the conductor wire. It is treated as what? zero resistance will treat it as. Okay, so only the resistance of the resistor will be opposing the flow of electric current, and the voltage applied and the current flowing, application of voltage, current flows to the circuit, and this current, let's say what we can say it as our current, amount of current which will be flowing through the circuit will be what? Dependent on the resistance which has been connected at the load. Okay, so the resistance or the resistor which has been connected at the load, and it depends on the resistance value. More the resistance current will be less the resistance current will be more. Okay, so resistance, when the resistance is more, we have a lot of opposition, or we have a congested way to move. Okay, so when we have less resistance, so we have free road to move, so that we can move, like we can go like anything. Okay, so this is the general thing, or what we can say important thing about the voltage application and the current which is flowing and the resistor or the load connected. So each and everything. So if I have certain load or I have some bulb connected, so that bulb can be represented in the circuit in the form of what? A resistance, or the load resistance we'll call it as. Okay, so load resistance, or any of the thing in the universe will have certain resistance for the flow of electric current. Okay, something will have less resistance, something will have more resistance. Okay, is that okay? Is that clear? Yes. Now coming to the voltage drop. Okay, so the topic voltage drop, we have to understand this very carefully. So coming to voltage drop, what is voltage drop? When I have when we give some voltage to, or certain voltage to the circuit, and this, and here we have conductor wire. Because of this voltage application, current starts to flow, and this current comes and reaches the end of the resistance. Okay, so the current flows from positive of the supply towards negative of the supply. Here it should go to ground, isn't it? So here, when this current flows, when this current reaches here it has got resistance, and here comes the opposition. So how we can make out this as? So that will be, so when we have given certain voltage and current is flowing, when this current reaches here there is an opposition for your current to flow, isn't it? So we have a resistance, and what happens here is, so this voltage, the voltage will be carried by the voltage will be carried in the form of what? Current, isn't it or not? So the voltage which is there here, so this voltage will make your electrons to move. Electrons will be moving from negative of the battery towards what? Positive of the battery, and in the opposite direction of the electron motion, we can say it as what? The electric current, isn't it? So we have discussed all these things before, isn't it? Yes. Now what happens here is, when the current is flowing, here the voltage will be dropped. Voltage will be dropped across the resistance, because here there is an opposition, isn't it? So the voltage will be carried in the form of what? Current, and when it comes here there is an obstruction. Okay, here there is a opposition, when it does what is, it will drop the voltage, so whatever it is carrying, because the voltage what we have here and the current what will be flowing here, the current will be the product of what? The voltage, isn't it or not? The voltage what has been applied, because of this voltage this current is flowing, isn't it or not? So this voltage will be carried by the current, and when it comes here, it will drop that voltage across the resistance, because here there is an opposition for the current to flow, and there comes the voltage drop, and whatever the voltage what we have here, so the voltage or potential difference what we have here will be appeared across the resistance, being this terminal positive, this terminal negative. Okay, so whatever the voltage you have here, so this voltage will be dropped over the resistance R. So how it happens is, so something like that. Okay, so here what we can make out is, in another way also what we can go for the measurement, or here we can say that the total voltage will be dropped here. Okay, so how this voltage will be dropped here? So if I consider these 2 points, there is a potential difference, or potential difference, or there we have a voltage difference of what? V volts from this end to this end, and coming to this copper wire, So this is what a conductor wire, isn't it? If I go for these 2 points, this will be V will be the voltage. If I go for these 2 points, voltage will be same, V volts, isn't it? If I go for these 2 points, voltage will be what? V volts, isn't it? If I go for these 2 points, what will be the voltage? It will be what? V volts, isn't it? If I go for these 2 points, what will be the voltage drop? Again V volts. If I go for these 2 points, again voltage drop will be what? What is the difference in voltage between these 2 points? Will be V volts, isn't it? So coming to this and this point, again the potential difference will be what? V volts. Is that okay? Is that clear? So this is how I can say that the total voltage will be dropped across the resistance V. So this is what is what? Voltage drop. Okay, so whenever the current flows through, and if I have some resistance or some load we have, load will have certain resistance definitely, and because of this resistance, the voltage will be dropped across the resistance or resistor which has been connected at the load. Okay, so because of this, we have this concept of voltage drop, and applied voltage will be totally dropped over this resistance R. Okay, so the current will depend on the application of voltage and the resistance inversely, and V is directly proportional to I, and thus we have certain voltage drop. This thing or this concept also we can make out like this. If I have some if I have a road, okay, I have some wave or some road, we have one way for traveling or whatever we have. We have some we have a road, okay, which is in front of our house, wherever it may. Okay, so there is some dig. There is some dig in the road. Okay, so there is a dig in the road. So what happens here is, if the water is flowing like this, that means what? I can consider this water flow as what? I. Okay, so the water is flowing in this direction. Here there is a dig. Okay, here there is a dig in the road. Okay, the water is flowing. So what happens when this water comes here? So water comes here. When this water comes here, there is an obstruction for the water flow. Isn't it or not? So here there is a dig. Here there is a dig means what? The water will be stored. Here, the water will be stored here, and rest of the water will flow like this. Isn't it or not? Okay. So when this fills up, rest of the water will be flowing like this. Isn't it or not? Okay. So what happens here is, so the current I is flowing, and here there is a dig. So there appears a voltage drop. Okay. Is that okay? So we have a resistance for flow of current. So there appears to be what? There appears a voltage drop V. Okay, so dig means what? Some obstruction for your dig people are aware of, isn't it? So we have a plain road, here we have a dig. So here water is flowing and water will be stored, water will be dropped, or voltage will be dropped. Okay, in that dig, and thus later on it flows in the other direction and it goes to wherever it wants to go, isn't it? So in this way we can make out the voltage drop in the scenario of what? The road and a dig in the road, and when water flows, we have resistance for water flow, so there comes the voltage drop. Okay, so water will be stored over there, so that is what is what, like what that we can store water, I can think as what? Voltage drop. So that is what the actual voltage drop which is going to happen here. Okay, so in the same way that we have voltage, current is flowing, there is an obstruction, voltage will be dropped across, and the current continues to flow to ground, and it happens to be a continuous process, so that current will be flowing and the load will be utilizing the voltage applied in the form of current. Okay, yes. So this is how we can have this voltage drop idea. Okay, so here because with all these things, so next thing we will consider about the resistances connected in series and parallel. Okay, so we have a single resistor here. So now we will be seeing resistance is set as what? Certain, like so much amount of ohms, isn't it? Like some ohms of resistance that resistor will have. So likewise, if I have different like if instead of one resistor, if I have two resistors or three resistors, so how I can make out the total resistance if they are connected in series or parallel? So that will be the next topic we will be discussing. Now we will consider another thing over here. So we have in this circuit we have only we have only one resistance. Okay, so with a voltage source we applied and current I flows through the circuit and voltage will be dropped. The total voltage will be dropped across the resistor R. Okay, so here I have to take two of the resistors. Okay, so here what I have done is I have taken two of the resistors which are connected side by side. Okay, so what kind of combination is this? So we will discuss next. Okay, so what I am going to show you is, so about the voltage drop I will be talking here. So I have connected two resistors here. Here we have only one resistor, and here we have two of the resistors connected side by side. So now what happens is, so now I have certain voltage applied V here and current I starts to flow, isn't it? I have applied DC voltage of V volts and current I starts to flow here. So before here and then here comes the question of voltage drop. So what happens here is, so I have certain voltage applied, current starts to flow and the total voltage will be dropped across this resistance R. Okay, so now because here there is only one person, I have a chalk piece. So what I have to do is, so this total chalk piece has to be given to this person, because like they have only one person, isn't it or not? So I have only one person here, so the applied voltage will be given to this person totally, isn't it? So this the voltage, total voltage will be given to this person. Is that okay? So because here there is only one person, I have one chalk piece, I have to give it to him. So I need not do pieces, because here there is only one person. Okay, so when it comes here, we have two persons here, R1 and R2. We have two resistances. Okay, so R1 and R2. So I have applied certain voltage V here. So current starts to flow, and there are two resistances connected. So what happens here is, so we have a chalk piece. I have to give this chalk piece to two of the people. So what I have to do is, so this chalk piece will be splitted, or this chalk piece will be made into two pieces. So then I have to give one piece to this person and another piece to another person. Fine or not? Okay, so likewise what I have to do means the applied voltage will be given to the resistances R1 and R2. If in the situations when we have more than one resistances, the voltage will be divided into two of the resistors. So that means what? Some of the voltage will be dropped here and some of the rest of the voltage will be dropped here. So this voltage I can call it as what? V1, and this voltage I can call it as what? V2. The voltage drop across resistance R1 is what? V1. Voltage drop across resistance R2 is what? V2. So in this way we can say V1 and V2, because of the applied voltage, the total voltage will be made into two parts, and one part will be dropped across R1, while other part will be dropped across what? R2. So this is a particular combination of resistance. I am telling this in the form, like in the context of what? Voltage drop. Okay, so there is only one person or only one resistance, total voltage will be dropped here. If we have two resistances or two digs in the road, if we have two digs in the road, some of the voltage will be dropped here, some of the voltage will be dropped here, and it finds a path to ground. Okay, so in this way the voltage will be divided into two parts, here and here. Okay, so these things you will be considering in the next topic. So what is that? The connection, series and parallel combination of resistance, and therein we will be discussing these things in detail. Okay, so this is all for this class. Okay, thank you.